Welcome to the course Signals and Systems Session 2. In previous lecture we have seen the different type of two signals, that is continuous time signal and discrete time signal. Now here we observe some math behind to conversion from continuous time to the discrete time. The discrete time signal is obtained from the continuous time signal where the independent variable t is replaced by nts. So the relation, that is small t equal to n into capital Ts, where capital Ts is the fundamental period of the signal and the reciprocal of this thing is 1 upon fs. So that's why this t equal to n into Ts, that is equal to n upon fs. Let us consider a continuous time signal and we need to convert into the discrete time domain. So let us x of t equal to a cos 2 pi f into t plus theta, where f is the frequency, a is the amplitude and theta is the phase of continuous time signal. Now replace this small t by above relation, that is n into ts, which is equal to a cos 2 pi f into n ts plus theta, which is equal to a cos 2 pi n into f divided by capital Fs by using the reciprocal relation of ts plus theta, which is equal to a cos 2 pi n into f0 plus theta, where capital F0 is the frequency in discrete time signal. This can be mathematically represented as f0 equal to f upon fs, where small f is nothing but the analog frequency, capital Fs is nothing but the sampling frequency, and this is nothing but the discrete frequency, or we can say digital frequency. This relation, hence, the discrete time signal can be specified by a discrete set of value. The set of integer is an example of discrete set of values, and the example is shown below. That is x of n equal to 0, 1, 0, minus 3 and so on. The arrow indicate below the 0 is nothing but the sample at origin and similarly represented in the graphs. Okay. So remember one thing, in discrete time domain on x-axis the time is represented by small n, y-axis the amplitude is there. Okay, and the representation signals are discrete in nature, the samples are there. Similar example are shown in the next slide also. You can go through this one. Here arrow is at 4, so you observe this positive side as well as negative side signals. Next, analog signal and digital signals. The continuous time signal alternately we called as analog signal because of some physical phenomena analogy, and hence the analog signal has same continuous in amplitude as well as continuous in time. When analog signal is sampled with uniform rate, then it will be converted into the discrete time domain, and hence accordingly these signals, discrete time signals, are continuous in value, that is in amplitude, but discrete in time domain. And the third one, that is the next version of discrete time signal, is nothing but the digital signal, and which is both are in discrete in amplitude as well as in time, as well as in finite set of numbers. That's this type of signal is called as digital signals. Okay, for example, the temperature measurement of for the day. Okay, we can count the temperature at 9 a.m, at 40 a.m, at 12 a.m, or 1 p.m, 2 p.m, and so on. Okay, so this is countable numbers are there and finite set of values. Such numbers are called as digital numbers or digital signals. Now, the classification of continuous time and discrete time signal based on their natures, that is periodic and non-periodic signal, even and odd signals, energy and power signals, deterministic and non-deterministic signal, which is also called as random signals. So first 3 points are very important corresponding to the theory examination as well as for online examination. Always there is one or two questions out of this first 3. Now, last random signals we will deal with these signals in unit number 6. But here we need to know the difference between what is meant by deterministic signal and what is meant by random. Now, first we will go through the periodic and non-periodic continuous time signal. So, continuous time signal is represented by x of t, which repeats itself after the fixed time period for infinite time, is called as periodic signal. And its a mathematical representation is like this: x of t equal to x of t plus n into t0 for any integer value of n For n equal to 1, this relation becomes x of t equal to x of t plus capital T0. This condition is called condition of periodicity, where T0 is the constant, or we can say fundamental period. The smallest possible value of T0 that satisfy the above condition is called period of the signal x of t, or we can say fundamental period. Now let's just a view of periodic signals, that is examples on periodic signals. So let us consider this is a voltage waveform represented by mathematically, that is x of t equal to a cos 2 pi f0 t plus phi. This is standard form, and this is the graphical form, where a is the amplitude of the signal, f0 is the fundamental frequency of the signal, t0 is the fundamental period, which is a reciprocal of fundamental frequency f0, and phi is the phase of signal. Now here observe that this period t0, that is time required for one cycle. This cycle is repeated infinitely, from minus infinity to plus infinity. For the infinite, this time period is repeated for infinite time period. Due to this, such type of signals are called as periodic in nature. Remember, all continuous time sine and cosine signals are always periodic. Whether the periodic period of the signal may be rational number, may be irrational number, may be a fraction, but individually all continuous time sine and cosine signals are always periodic. Second point, if the two signals x1 of t and x2 of t are periodic for the period t1 and t2, then the sum of the signal x1 of t plus x2 of t may or may not be periodic. The sum of signal is periodic if the ratio of their two period is a rational number, or we can say ratio of two integers. The periodicity of the resultant signal is the least common multiplier of T1 and T2, which is called as fundamental period or period of the given signal. We'll see in example how to calculate the period and this. Next, periodic discrete time signal. Similar to the continuous time, discrete time signal x of n, which repeat itself after the fixed time period for infinite time, is called as periodic signal, and it is represented by x of n equal to x of n plus capital N0. This condition is called as condition of periodicity, where N0 is the constant. The smallest possible value of N0 that satisfy the above condition or periodicity condition is called the period of the signal x of n, or you can say fundamental period. Note here, if the two discrete time signal x1 of n and x2 of n are periodic for the period n1 and n2, then the sum of signal x1 of n plus x2 of n is periodic always. The periodicity of the resultant signal is the least common multiplier of n1 and now we'll just go through this non-periodic. What is meant by non-periodic analog signal? Here analog signals x of t, which is not repeating itself after the fixed time period for infinite time, is called as non-periodic signal. The mathematical expression for the non-periodic signal is like this. It does not satisfy the periodicity condition. Okay. This type of signal is called as non-periodic signal. An example of non-periodic signal in continuous time domain is shown here. This is exponentially decaying signal. The time period is up to infinity plus infinity, but this same period cannot be repeated up to infinite period. Hence, it is called as non-periodic signals. In discrete time domain, the same relation, just replacing the notation, that is t by n. So here is discrete time signal x of n, which is not repeating itself after the fixed time period for infinite time, is called as non-periodic signal. And the mathematical expression is x of n is not equal to x of n plus n0. An example of non-periodic signal is shown like this. This does not repeat itself. So because of this, this is called as non-periodic signal, and this is known as exponential sequence, non-periodic exponential sequence. Now in next section we will solve some problems on periodic and non-periodic signals, so you can understand thoroughly how to calculate, how to determine the signal may be periodic or non-periodic.